Before we start this unit on atoms and the history of the atom and also nuclear chemistry, I want to see what you know from previous science classes. Stop the video and answer these three questions. Okay, we're back. How did you do? What are the three parts of an atom? They are protons, neutrons, and electrons. And where are they located? The proton and the neutron are located in the nucleus, and the electron is located outside the nucleus. Number three, what is the difference between fusion nuclear reaction and a fission nuclear reaction? In fusion, you are taking two smaller nuclei and combining them to form a large one. So that the second picture there shows that. And a fission nuclear reaction is where you have a large atom and you bombard it with something and it splits into two medium-sized atoms. Okay, let's first talk about some atomic laws and some general chemistry laws. And the first law we're going to talk about is the law of conservation of mass. And in the law of conservation of mass, it says that in a closed system, the mass of the reactants equals the mass of the products. And so here I have a picture of a chemical reaction before it's taken place. And I have a mass of 300.23 grams. And then I go ahead and combine the two contents together, and I have a chemical reaction take place, a precipitate forms. And if you look and see the mass after the reaction, it's the same mass as what we started with. And so this is the law that matter cannot be created nor destroyed. Now take a look at this candle. Now looking at this candle, I could take the mass of the candle before, and I could take the mass of the candle after I burn it for an hour. And you might say, well, the mass disappears. That is going against the law of conservation of mass. But remember, in the law of conservation of mass, it has to be a closed system. And this candle is open up into the air. So if I were to dome it and take the mass before I burned it and the mass after I burned it, you would still find that the mass before and the mass after the reaction is still the same. And where this candle went is it became gases in the container. So we did have a chemical reaction taking place. The height of the candle did go down, but in the course of the chemical reaction, the solid wax turned into a gaseous product. So again, even though it looks like we destroyed matter, it's still there. It's just in a different form. It's in the gas particles that are in the container. And so let's look at this general chemical reaction. We have reactants A and B. And remember, reactants are over here on the left-hand side. So these are the reactants. And I have products over here. And if I were to measure the reactant A and find it to be 1 gram and reactant B to be 0.5 grams, and then over on the right-hand side, I have product AB, what would you predict the mass of A and B, of product AB? And you would predict, you would just add these up, and you would get 1.5 grams. So again, we have the mass of the reactants totals 1.5 grams, and it equals the mass of the products. This is the law of conservation of mass. And this is why equations are balanced. So in this chemical equation here, we use the symbols of the elements to represent atoms, and you have to have equal number of atoms on each side. So if I look on the left-hand side, I see that I have 2 hydrogens, and over here I have also 2 hydrogens, so those are balanced. I have 2 oxygens, but over here I only have 1 oxygen. So I need to put a 2 in front of the H2O. This now changes my hydrogens. So I have 2 times 2, 4 hydrogens on this side. So I need to put a 2 on this side to get 4 hydrogens on this side. So this is balanced according to atoms. So I have 4 hydrogen atoms on each side and 2 oxygen atoms on each side. So my law of conservation of mass is conserved. So the scientist that came up with this law is Antoine Lavoisier, and he was a Frenchman. And he, besides just being a scientist, and taking careful measurements and discovering this law of conservation of mass, he was also a tax collector. And so during the French Revolution, because he was a tax collector, he was hauled in front of a French judge when the people rose up against the aristocracy. And Lavoisier pled for his life. He did not want to be sent to the guillotine. He said, I have chemistry experiments I need to finish. And the judge looked at him and he said, France does not need scientists. And Antoine Lavoisier did lose his head to the guillotine. His wife, Marie, she was a scientist in her own right. She participated in all the Lavoisier's experiments, and she kept careful notes for him. And it's through those notes and the careful observations that he was able to discover this law of conservation of mass. And Antoine Lavoisier is known as the father of modern chemistry because his observations were so detailed and he was able to take good data. All right, let's look at a second law. This is the law of definite proportions. So a scientist by the name of Proust was the one that discovered this. Again, right around the same time as Lavoisier's time. And this law of definite proportions says that if the ratios of elements in a substance are the same by mass, then the substances are the same. And a good example of this is, let's say I have some water that I took from a lake and I have some water I took from a glacier. Is it the same substance? And you might say, well, of course it's H2O, but this is 200 years ago and people didn't know about H2O or even the formula of water. All they knew that it was clear and then they knew that they could that it was composed of hydrogen and oxygen. So Proust, he took careful measurements just like Lavoisier did, and he, for example, in this example here, let's say he took his sample of water and he has 2 grams of hydrogen that he was able to split the water and generate, and he's able to have 16 grams of oxygen. Well, what is the ratio by mass? To figure this out, you always divide by the lowest number. So I'm going to divide each of these by the smallest number, which is 2, and I end up with a ratio of 1 to 8. And so this is 1 part hydrogen and 8 parts oxygen. Let's see how it compares to the glacier water. So again, look at your numbers and divide by the lowest number, which is 4. So I end up having a ratio of 1 to 8. So because the ratios are the same, then I can say that these two substances are the same. So this is the law of definite proportions, meaning that when I have a compound, it has the exact same ratios of elements no matter where I get the sample. As long as it's the same ratio, then it's the same compound. So the law of definite proportions, compounds have definite formulas. This next check is just to see if you understand the law of definite proportions. Answer the questions. And so stop the tape and then answer the questions and then restart the video. Okay, we're back now. So looking at question number 1, are these all the same compound? And the answer is no. So I do have some differences here. So this one, I tried to make the math easy on this one. This one has a ratio of 1 to 8 hydrogen to oxygen. And the second one also has a ratio of 1 to 8. Remember, you find the ratio by dividing by the smallest number. So I have a 1 to 8 ratio. And let's look at the last example. Divide through by 2 each one, and I end up having a ratio of 1 to 16. So compound C is different, but A and B, they are the same because they have the same ratio by mass. And let's look at the number 2. What did you get for that? You should have gotten that they are the same. So yes, they are the same compound. So notice that we do not always have to have a whole number ratio, and the 1 doesn't always need to come first. So this is a 2.7 to 1 ratio of oxygen to carbon. And if we divide through by the smallest number of the second one, we find that we have the same ratio, 1.7 to 1. So these are both the same compound. All right, our third law is the law of multiple proportions. And an Englishman by the name of Dalton is the one that discovered this. And he was a studier of gases and their reactions. And he noticed that some elements combined in different ratios. So, and this is way back when before they even knew formulas, but it kind of helps, I think, to see that there is a formula associated with this multiple proportions. So down here we have two different substances that both have carbon and oxygen in it. So if I look at how much oxygen is in the first one and how much oxygen in the second one, I see that if I divide through by the smallest number, which is the 16, that the oxygen by mass, it's doubled in the second compound. So it's a ratio of 1 to 2 between one compound and the next. And so this is, again, the law of multiple proportions. Elements combine in small whole number ratios. So you're never going to get CO 1.7. You can have CO or CO2, but never something that is right in the middle. And again, Dalton discovered this by doing careful observations and noticing that when you did have substances that had different ratios, that there were always a whole number increase by mass. So this is a law of multiple proportions. Some compounds some elements can form multiple compounds.